A very good morning to you. Principles of Geochemistry, Structure and Composition of Meteorite, Lecture 5. Coming to the contents of this topic, this includes meteorites, introduction, classification of meteorites, stony meteorites, stony iron meteorites, tektites, and summary. Coming to the meteorite. Meteorite is a piece of rock from outer space that strike the surface of the earth. So these are known as any extraterrestrial material which hit the surface of the earth. A meteorite is a meteorite before it hits the surface of the earth. Meteorites are extraterrestrial objects composed of a variety of materials. They are broadly classified as main categories like stony meteorites, iron meteorites, and stony iron meteorites. Stony meteorites, they are primarily rocks with iron and nickel, often making a small portion. Iron meteorites are largely metallic, composed of iron and nickel with trace amounts of other elements. Stony iron meteorites are mixtures of both rock and metal with a variety of compositions. These are also known as shooting stars. And the rate of the meteoritic fall, it is between 30,000 and 1,50,000 tons annually. So as they have classification like iron meteorites, and then stony meteorites, stony iron meteorites, and they may be consist of nickel iron alloy, and they consist of crystalline silicate like olivine or pyroxene, and they also consist of troilite, iron sulfide mineral, a mixture of sedimentary or metamorphic rocks. So these are different meteorites which hit the earth. Coming to the meteor showers, many meteorites are seen during specific seasons of the year when the Earth's orbit passes through a belt with a high concentration of dust or cosmic dust and other particles. Passing through one of these belts each year in mid-August, it causes the Perseid shower, the Linoid shower, which happens around in the middle of the November. So these are different meteorites which are hit in 1938, 1954, 1992. Like that, meteorite showers have been, or meteorite dust can be seen in several parts of the globe. In 1938, a small meteorite has crashed through the roof of a garage in Illinois. And in 1954, a 5 kg meteorite fell through the roof of a house in Alabama. Like that, you can see a number of meteorites which has hit the earth. Coming to the classification of the meteorite. Modern classification, it divides the meteorites into groups according to the structure, chemical composition, and mineralogy. Modern classification of meteorites, it is very complex. There are 4 meteorite types like that: Aerolites, Siderites, and Tektites. So coming to the detailed classification of the meteorites, these are divided into 4 sections. Number 1, stony meteorites. These are also known as Aerolites or stones. Again, they are divided into chondrites and achondrites based on the presence of chondrites. Coming to the second category, stony iron meteorite. These are also known as Siderolites. They consist of 50% metal and 50% silicates. Again, it includes 2 main types like Pallasites and Mesosiderites. Coming to the third category, iron meteorites. These are also known as Siderites, average about 98% metal. And they again divided into hexahedrites, octahedrites, and ataxites. And coming to the fourth category, these are known as tektites. Coming to the first category, stony meteorites. These are also known as aerolites. They consist of 90% of silicate minerals and 10% iron nickel alloy. Stony meteorites, they can be classified as chondrites and achondrites. On the basis of texture, the aerolites are stones. They are again divided into chondrites and achondrites. So these are essentially rocks from space, often containing small grains of nickel and iron and sometimes other minerals. The chondrites are so named because of the presence of chondrules or chondri, which are small rounded bodies averaging around 1 millimeter in diameter. Mainly they consist of olivine or pyroxene. Coming to the chondrites classification, they consist of 40% olivine, 30% pyroxene, and 10% plagioclase, and 10% nickel iron alloy, and 2% native copper, and 2% copper, 2% chromite. The presence of condyles or chondri, which are small rounded bodies averaging around 1 millimeter in diameter, consisting of olivine or pyroxene, and these are similar in composition to the mantle and the crust of the earth. And chondrites are believed to be among the oldest rocks in the solar system. And carbonaceous chondrites, that is around hydrous iron magnesium silicate, and contain 10% complex organic compounds. Coming to the achondrites, so they consist of 80% pyroxene and plagioclase, 10% iron nickel alloy, 2% magnetite, and 2% chromite. And these chondrites, achondrites, they lack chondrules, and they resemble igneous rocks on the earth. And Murchison meteorite, they fell in Australia in 1969. It is of achondrite, and these are of non-biological origin for organic compound. Coming to the stony iron meteorite, these are also known as the siderolites. The siderolites are stony meteorites. They are made up of nickel, iron, and silicates in equal proportion. There are again two distinct groups like Pallasites and Mesosiderites. What are Pallasites? Pallasites are continuous base of nickel iron enclosing grains of olivine, which often they show good crystal forms. Coming to the Mesosiderites, so here the metal phase is discontinuous and the silicates are mainly plagioclase feldspar and pyroxene. Sometimes they contain accessory olivine as well. Coming to the iron meteorites, third category, this is also known as Siderites. So one or two nickel metallic phases and accessory troilite, that is iron sulfide and graphite. And they also consist of Daubreelite, FeCr2s4. Daubreelite is a rare sulfide mineral and it crystallizes in the cubic system and it typically forms black platy aggregates. The mineral is a member of the linite subgroup with the largest spinel supergroup, and it was named in honor of the Gabriel Auguste Daubry, a French mineralogist and geologist. And there are accessory minerals which are present in iron meteorites as a small rounded or lamellar grains scattered throughout the petal. And these siderites, they have a peculiar pattern. This is known as a Widmanstatten pattern. Metals generally show a definite structure. This is known as a Widmanstatten structure or Widmanstatten pattern. So this can be brought by etching the polished surface with alcoholic solution of nitric acid. This structure consists of a lamellae of camosite, a nickel iron alloy with 6% nickel, which is bordered by tennite. Tennite means it is a nickel iron alloy with about 30% nickel. So the Widmanstatten structure, it is distinctive. It is a lattice work-like pattern. This is found in certain iron meteorites and in some steels, which is formed due to slow cooling of iron nickel alloys. And it appears as intersecting bands of nickel iron phase. This pattern, which is a result of slow cooling and crystallization of these alloys deep within the planetary bodies, making it a key indicator of extraterrestrial origin for iron meteorites. And this structure is a typical of subsolidus exsolution, which is an alloy that has cooled very slowly from a high temperature. Subsolidus exsolution is a process where a single homogeneous solid solution mineral separates into two or more distinct mineral phases while remaining in the solid state, that means below the solidus temperature. This occurs due to changes in pressure or temperature that make the original solid solution unstable. The separated phase typically form intergrowths such as lamellae within the original mineral structure. Coming to the iron meteorites, so these are again divided into three types like hexahedrites, octahedrites, and ataxites. Hexahedrites are irons or iron meteorites consisting entirely of camosite, whereas octahedrites, here the lamellae are parallel to the octahedral planes. An originally homogeneous crystal of nickel, iron, and meteorites showing Widman structures are therefore known as octahedrites. Then what are ataxites? Ataxites are nothing but the iron nickel alloy, which is composed of chamosite and titanite. The concentration of nickel is about 14% and consists largely of olivine tennite. These are some of the pictures of iron meteorite. Tamintet iron meteorite. This is found in 1864 in Sahara. This is roughly weighs about 500 kg. And polished surface of meteorite glowing iron and nickel, you can see here. Coming to the fourth category of meteorites, these are tektites. Tektites are derived from the ancient Greek word tektos, which means molten, and are gravel-sized structures made of natural glass that is black, green, brown or grey, and is created when meteorites strike the earth. The term tektites was coined by Austrian geologist Franz Edersses, son of Edersses, and they generally range in size from millimeters to centimeters, and millimeter scale tektites are known as microtektites. And in the figure, you can see two splash form tektites. These are molten terrestrial ejecta from a meteorite impact. Tektites are characterized by a fairly homogeneous composition and an extremely low content of water and other volatiles, and an abundance of lechatillerite. This is a naturally occurring amorphous glassy form of silica that is common diagnostic component of tektites, and they generally lack microscopic crystals known as microlites, and they do not have a chemical relationship to the local bedrock or local sediments, and their distribution lies within geographically extensive strewn fields. And tektites are superficially similar to some terrestrial volcanic glasses. These are also known as obsidians, and they are completely glassy and lack any microlites or phenocrysts, unlike terrestrial volcanic glasses. Although they are high in silica, the bulk chemical and isotopic composition of tektites is closer to those of shales and similar sedimentary rocks. And the flow banding within the tektites often contains particles and bands of lechatillerite, which are not found in terrestrial volcanic glasses. And a few tektites, they contain partly melted inclusions of shocked and unshocked mineral grains, that means quartz, apatite, and zircon, as well as coesite. Coming to the classification of these tektites, again, these tektites, they can be subdivided into four groups. They are: number one, splash form. These are also known as normal tektites. And number two, aerodynamically shaped tektites. And number three, Mueang-Nong type or layered tektites. And number four, microtektites. In the figure, you can see splash form tektites and aerodynamically shaped astrolite. Coming to the summary, any extraterrestrial material hitting the earth is known as a meteorite, and a meteoroid is a meteorite before it hits the surface of the earth. There are four meteorite types known as Aerolites, Siderolites, Siderites, and Tektites. And stony meteorites, these are also known as Aerolites. They consist of 90% silicate minerals and 10% iron nickel alloy. And stony meteorites, they can be classified as chondrites and achondrites. On the basis of texture, aerolites or stones are divided into two groups. These are chondrites and achondrites. And the Siderites are stony iron meteorites made up of nickel iron and silicates in equal concentration. Siderolites are further classified as Pallasites and Mesosiderites based on the base of nickel iron enclosing grains of olivine and pyroxene. Siderites consist of one or two nickel metallic phases and accessory troilite, so its chemical composition is iron sulfide, and graphite, Daubreelite, that is iron chromide sulfide, and one or two nickel metallic phases. Accessory troilite, graphite, Daubreelite, all these are the constituents of the siderites. And metal generally shows a definite structure known as Widmanstatten pattern. And tektites are gravel-sized bodies composed of black, green, brown, or grey natural gas that is formed from terrestrial debris which is ejected during meteorite impacts. And these tektites are superficially similar to some terrestrial volcanic glasses. These are also known as obsidians. These are the references. Thank you for your time. See you in the next video.